Good evening and Salam Madani, Malaysia. We are Malaysia. We are from Mathematics Department, Institute of Teacher Education, Penang Campus, Malaysia, organizing this webinar session today with our distinguished guest speaker, Prof. Dr. Zsolt Lavicza from Linz School of Education, Jonannes, Kepler University, Austria, with the title of STEAM in Mathematics Education today. Dear ladies and gentlemen, before we start our program today, let us call upon our Honorable Director, Dr. Azman bin Juso, to deliver his keynote speech. Welcome, Doctor.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. And good afternoon to everyone. First of all, I would like to express my gratitude, warm welcomes and sincere appreciation to our honorable guest, the panel of the webinar, Professor Dr. Zsolt Lavicza from Linz School of Education, Jonannes Kepler University, Austria, for willing to share his experience in our programs. I'm also wanting to say thank you and welcome to every one of you for taking time to be part of our webinar, and your presence here is genuinely appreciated. For your information, ladies and gentlemen, the webinar has been organized by the team of mathematics lecturers in our campus, and the purpose is to discuss about STEAMs in mathematics education. I do believe that the topic is significant to everyone, to the educators, to the lecturers, students, and all the participants of the programs. Today we are very happy because we have a Professor Dr. Zsolt Lavicza to share his knowledge and insight on STEAMs in mathematics education. This is an excellent opportunity to enhance our understanding and contribute to our personal and professional growth. As a teacher training institute, which is focused in the science and mathematics education, our responsibility is to plan and to implement the programs that we believe at the end of the programs our students will acquire the skills, knowledge, and attitude as a future science and mathematics teachers in our country. Once again, thank you for being here in our webinar, and let us make the webinar as a meaningful experience for everyone. Thank you very much.
Hi, audience. Ladies and gentlemen, welcome back. Now it's time for me to introduce our panel moderators here. That's me, Dr. Kalewani Shanmuga, lecturer from Mathematics Department. Here with me today is our Head of Mathematics Department, Dr. Lavaneswari Manogaran. Together with us here is our Deputy Head of Mathematics Department, Dr. Norabiatul Adawia Abdul Wahid. Yes, now over to you, Dr. Lava, to introduce our guest speaker today. Thank you.
Thank you, Dr. Kalai. With this busy schedule, we appreciate Professor to attend here virtually. Professor Zsolt Lavicza is from Linz School of Education, STEAM Education Center, Johannes Kepler University, JKU, Austria. After receiving his degree in mathematics and physics in Hungary, he continued his postgraduate studies in applied mathematics at the University of Cincinnati. While teaching mathematics, he became interested in researching issues in teaching and learning mathematics. He focused on investigating issues about the use of technology in mathematics education. This includes developing research projects on GeoGebra. He has worked on several research projects examining technology and mathematics teaching in various classroom settings. He has collaboration with various universities out there, which includes University of Michigan and University of Cambridge. So far, Prof has more than 300 publications in mathematics education and technology integrated mathematics education. Currently, Professor is working on numerous research projects worldwide related to technology integration in schools, doctoral program in STEAM education, teaching educational research method, and numerous research projects with the International GeoGebra Institute.
Okay, by listening to Prof's background just now, I believe our audience and us too, the moderators, are really excited to ask questions and share our valuable insights and ideas and maybe questions regarding STEAM. Therefore, we really hope that we can have an active audience who will participate by post comments, questions, and also inputs and insights at the comment sections. At the end of our session, after Prof. Zsolt has finished his sharing session, we will read out maybe one, maybe two, and maybe more than that questions, comments, or and insights that we have received at the comment sections. And hopefully, Prof. Zsolt will respond to your feedback. So, moderators,
Yes.
can we pass our mic to Prof. Zsolt now?
Sure. Yes.
All right, Prof. It is your floor now. Let's start our session.
Yes, thank you very much for the kind invitation, and I'm very happy to be here. And I have very good memories from Penang. I was there in the Summer Center giving a talk before COVID, so I know that our um, time is starting before and after COVID. And I had very good experiences in Malaysia. I was in Kuala Lumpur at UPM and in Malacca in different conferences. So I really appreciate your country and the place. So will you share my slides? Yes. Okay. So thank you for the kind introduction. I'm very happy to be here. And so today I will talk about STEAM education. So as it was mentioned before, I'm originally a physicist and mathematician. But when I studied in the US applied mathematics, I realized that it's very important to improve mathematics teaching. And then I started to use technology to integrate into mathematics education, and that's how I went to the University of Michigan. And then afterwards, I was working in Cambridge University for 13 years. But my background is more mathematics. But at the same time, what we realized during the year while developing GeoGebra and then also working on research, that mathematics shouldn't be completely isolated from the other subjects. So we started to work on STEAM education, that how do we connect different subjects and then how we can make meaningful activities for students. So today I will talk about one of the topics of our research group, which is 3D modeling, 3D printing, augmented reality, and then virtual reality. So I will give you a little bit of background, some research projects, and then also we are working on innovation, and then we are working on innovation on different topics, but also we are working on innovations on theories and methodologies. So if there is time, I will share it with you, and then maybe you can remind me that how much time I have. So just a little bit of background, that where I'm coming from. So, as I mentioned, I was working in Cambridge University, leading the doctoral program. But I was invited to Linz to set up a doctoral program in STEAM education. So currently, we have more than 40 PhD students, and we are developing a research center here with lots of visitors and collaborations from all over the world. And for example, this week we have 7 visitors from many countries, from Indonesia, Argentina, Italy, Egypt, um, I don't know, Spain, and Brazil. So we had a very full week of workshops. So essentially, what I will show today, it would be very good to have in this kind of collaboration, and then essentially all of the projects which I show you have lots of publications, and we are very happy to collaborate with you, and then you can try our projects as well. And Linz is a very good place to work because we have lots of different projects and then different centers, which is developing innovation. So, for example, the Center for Open Digital Education, then the Mathematics Didactic Center, and then also we have a cool lab, which is computer science education, and we have lots of projects. So currently we are running about 25 projects related to STEAM education. And also, we are very privileged that we are working together with Professor Markus Hohenwater, who developed GeoGebra. So essentially, we are in the same floor together with the GeoGebra Center and the Developer Center. And then we will be able to develop technology and innovation together with the GeoGebra colleagues. For example, today we are working on an app to integrate mathematics and dancing. And then maybe next year you will already have a possibility to develop dancing and mathematics. Actually, yesterday we had a demo of how mathematics and dancing is used for teaching in Indonesia. My colleague is here, and then I think then there will be lots of opportunities. So GeoGebra is not only mathematics software, but it's used in many different subjects. And then we want to connect it with these different subjects. And then also GeoGebra has now more than 100 million users around the world. And I'm sure many of you are using GeoGebra, which is we are very delighted. And then also GeoGebra is used not only for secondary schools as we planned, but also from primary to university level. But then the main strength of this research and then also the development is that we are developing a huge community. So everyone is sharing their ideas. So there are more than 2 million resources available on the GeoGebra platform. And we have many different GeoGebra Institute, including Malaysia, several institutes in Malaysia, Thailand, Indonesia, Korea, in different places. So this is the introduction of our institute. But what I would like to show you some examples on STEAM STEAM innovation, and then I picked the topic which is 3D modeling, which is becoming really important for our work and then in our society. And then of course it has lots of mathematical background in which is doing this kind of work. So essentially most of our work is connected to creativity and innovation. So what we want to do is trying to define that what is creativity. But there are many definitions, so we found more than 120 definitions. But what we want to do is to have this kind of definitions, and then we want to integrate creativities into this work. So we are not looking at one creativity, but looking at that how we can include different kind of creativities of students to integrate into the work. To do this, we started with mathematics, with GeoGebra, but at the same time, but we realized that we need to connect these subjects, and then we started to connect like mathematics and physics and chemistry and arts. But it's very important that not only connect the subjects, but creating an ecosystem or an environment where we can collaborate and then investigate different topics with this kind of transdisciplinary view. With my colleague in Cambridge, Bernard, we are developing this idea of transdisciplinarity. And also, we are working on this kind of development of technology. But we are developing the technology, but we also want to have the pedagogical policy and environmental conditions to be able to do this kind of work. So we have lots of different projects around, but today, as I mentioned, I will speak about 3D modeling. So why 3D modeling and why 3D technologies? Because it's becoming very important in our world. So students are living in a virtual environment, and then they are very proficient using 3D modeling techniques. But it needs to be integrated in the schools as well. And then also we are working a lot with 3D printing, augmented reality, virtual reality, which is becoming much more accessible. And in then that case, do you see my slides? Because I think on the screen, I think I lost the slides. Okay. Then so 3D printing, for example, can be used in architecture, in food industry, and then also now we can use it in biology, and then also we can have the different possibilities to have sustainable development. So, for example, 2 weeks ago, I ran a workshop in Charles University in Prague to integrate 3D printing into education and then work on sustainability. And then also, for example, augmented reality is becoming very important in every possibility in life. So, for example, AR can be used in the fashion industry, and then also we are using it in engineering. We can design augmented reality surveying tools and the virtual reality training. And with 3D printing, there is huge possibilities to create things which is which is used in many different industries. So, for example, automotive parts or any kind of parts can be 3D printed. Entire houses now can be 3D printed. And for example, airline engines, many of the parts are being 3D printed. So it's becoming a very important part of the work what we are doing. And then even in the space industry, we can now print rockets. And then also, then there is a possibility that we are bringing 3D printing into space, and then manufacturing all of the things that can be done in space. So then there are 3D printing everywhere. So for example, you can print food, you can print also clothes. So then there is this famous video when you can print clothes when you are moving and then individualize it. But very importantly, in biology and medicine, you can print entire cells and organs for this. So we are facing this kind of 3D modeling in education. What we try to do that we need to bring it to education, and then that's why we are doing lots of different projects, and that's what I want to focus today. That how do we bring this 3D modeling and 3D printing, augmented reality into education? So what we are doing is that we are creating lots of different activities. So we are working on different 3D printers, and then it's very important that teachers have to be ready for integrating 3D printing and 3D modeling into their educational practice. And we are doing lots of research. So whatever I show it to you, there are lots of studies behind it. After the talk, I will share you with all the papers. So we published more than 200 papers in that past 5 years around this STEAM education topic. So you can read about it, and then we can also collaborate and then run different workshops. So what we try to investigate that how we can bring this kind of 3D modeling, 3D printing, AR and VR into schools. And now we have a study to investigate that what is the problems in the schools within this kind of technology. Of course, when we started GeoGebra, it was a very big um, issue that how do students get access to the technology. And then that was a problem. But now every student has a cell phone and they can use GeoGebra. But this is the same is happening with this kind of new technologies. Augmented reality can be done already on the phone. 3D printing is becoming extremely cheap. So now we just get about 30 3D printers, and even many schools in Indonesia, which I know, and then also we work a lot in Latin America, in Uruguay. Every school has a 3D printer, and we need to find the possibilities to do this. So maybe there are some delays in different countries, but we need to prepare that this is a possibility in education. So what we can do is developing this kind of 3D innovation ecosystem with augmented reality, virtual reality, and 3D modeling. And we are doing different projects. So with augmented reality. So for augmented reality, you can use essentially any smartphone, and then you can have um, augmented reality. And if you look at GeoGebra, there is a possibility that you can just use GeoGebra to model anything. So then this is a teacher done this modeling of Pringles, and then you can use it in the classroom. But of course, we need to prepare the teachers that how to use in this kind of augmented reality software. But the good news is that the students are very proficient developing or using the augmented reality tools. So we are working together with the students, and essentially the role of the teachers should change to allow students to use in this kind of new technologies. Because of the games, there is a possibility that students are very proficient using it, and then we can integrate into the classroom and into the curriculum as well. And then also augmented reality can give us opportunities to integrate mathematical objects into our environment. So then this is the most ready technology. And then, for example, when you are teaching functions, instead of just showing the functions on the screen, you can just put these AR objects into the space, and then students can walk around and then use this AR tool to investigate the mathematical objects. And now we are working on multi-user environments, so students can use the classroom for doing this kind of modeling with augmented reality. And there is lots of possibility and lots of options what you can use with GeoGebra. Essentially, you can try it today. If you have a smartphone, then this is a possibility to do. So augmented reality is everywhere. And then what we try to do is trying to integrate augmented reality with other subjects. And then, for example, mazes are very culturally embedded in most cultures. So then there are mazes everywhere. But building a maze is difficult. But what we can do that we can build a maze based on augmented reality, and every student can look at design their own mazes and then solve their own mazes. And essentially, then this is the view how you design a maze with augmented reality and ask the students to walk around and then solve these kind of problems. And then it will give you lots of possibility to enrich mathematical topics that how do we design in this kind of mazes, how do we solve the these kind of activities, and then it gives a lot of encouragement for the students. So this is in our campus and at JKU, and then we are using this to use augmented reality. But also we are now experimenting with virtual reality, which is a little bit beyond what we are, what is mostly accessible in schools. But with virtual reality, you need headsets, but you can use your phone with a carton headset, and then we try to see that what virtual reality can give us. But then the main area of our research is 3D printing. So as I mentioned today, that 3D printing was very expensive, but essentially this is a very old technology. It's more than 40 years old. But now, because the patents expired, then there are lots of cheap 3D printing. 3D printers is becoming available. So you can even buy a 3D printer for $100, and which is working. But we are working together with 3D printing companies, and then fortunately we found a very accessible company, Prusha, who we can use our research to create 3D printers for schools. And we are working with 3D printers because if you buy one printer, then with this, for example, in this printer, you can print another printer. You just need to buy the elements of the printer, but you can essentially print your own printer with if you have one, and then that is a possibility. But our work showed us that if we are working with different kind of technologies, then we need to connect all of these subjects. So we are connecting physical and digital worlds, and we can use all the possible technologies and the work in this kind of case. And what we thought with my PhD students, that how we can make this physical digital connection, we started to design games. But it turns out that students are very proficient of designing different kind of games. So what we are doing now is preparing the teachers to allow the students to design their own games. And then what we are imagining that we are creating a new era of manipulatives where you can have physical and digital worlds connected with different technologies, and then we can use it with with the technologies, and then we can create very simple examples but very exciting examples for the students to, for example, design this spiral. It takes 5 minutes in GeoGebra, but you can use it in AR, you can print it, and then you can create puzzles, which opens the opportunity for lots of mathematical investigations. And also we are working with different games. So then this is a game called Logifaces. It's a very simple game with 13 prisms, and then you can create a continuous surface, and then it will be possible to have this game digitally and physically, and then it opens up lots of opportunities for teaching. We just published a book with 100 exercises integrating Logifaces into the classroom, and then you can use it in mathematics and then in many other subjects too. But we can use this, for example, for teaching 3D printers. So this is the same Logifaces game where the students have to design the 3D objects with a very thorough mathematical knowledge and then use it for 3D printing. And we had this idea that how can we inspire students to do their 3D modeling? And then we organized a competition with a very simple example that to design a cube from in which is divided into equal volumes. So how can we divide a cube with equal volumes. And there are infinite many possibilities. But students designed this cube in GeoGebra with lots of mathematical attention, and then we can print it, and then we can use it as a classroom tool or some kind of presence. Or, for example, very simple example that use the Voronoi diagram and then how to make a puzzle from the Voronoi diagram, so you can create it in a 3D environment, and then you can use it for this kind of work. And we had a project when we trained about 200 teachers in Montenegro to use 3D printing and then use it in their classrooms. So how can we use it in the classrooms? And then one of the teachers had the idea to create cookie cutters. So in that case, you can use these kind of cookie cutters to explore the geometry, and then we can use any kind of shapes. And then afterwards, if you cook cookies together with the students, you can eat mathematics and then discuss the topics together with them. And we used to have manual 3D printers when the students have to assemble the 3D printers by themselves. And then that is already an important project to investigate that how this kind of 3D modeling is working with the technology. And but now, because we have the new printers, we ask the students to create their own printers from scratch to understand that how 3D modeling is being done. And then also we create games together with teachers. So this is a very interesting game, and then this is the game which is done by a teacher in Luxembourg, and it's very interesting because you have parts of the puzzle in 3D printed form, and then the other part in augmented reality form. So you can only solve the puzzle if you use the physical and the digital representation of the problems. So in then that case, then this is a very interesting game to investigate the connections with the physical and the digital world. And then also we found a very interesting game called Polyuniverse, which is designed by an artist based on some Argentinian ideas. And then we can use this game for modeling in the classroom from kindergarten to university, and in many different mathematical topics, in geometry, in algorithmic thinking, and then also we can use it for combinatorics, but also we can integrate arts and mathematics. And then this is a very appealing game for many of the teachers. So we can use these kind of games, but also we can use our own environment. So we were thinking about that, how we can use any kind of environment, any classroom or any space or any city to use this kind of transition from the physical and the digital. And what we thought that STEAM education is integrating arts and creativity into mathematics classroom or any kind of subject classroom, but architecture is all around us. So architecture is surrounding us, and then we cannot really escape. But it's also it's an artistic feature, but also it provides lots of opportunities for mathematics learning. So we can turn a whole city or a whole country into a learning environment, and then you can do this investigation. So what we try to do is that using architecture to integrate it into the classroom, and then using different digital tools and physical tools to do this kind of modeling. So what we did is then that we created a dashboard for teachers to be able to do this kind of modeling in their classroom. So this is already available, but we are working on these examples. So you can choose the age of the students, that what kind of age you want to use in the classroom, what kind of technology you want to use for modeling, GeoGebra, 3D printing, laser cutting, origami, virtual reality, or any kind of modeling, you can choose that what kind of architecture you want to model. You can just use any house in your city, or you can use famous architecture. But also there is a possibility that not only using this mathematics in the classroom, but also go outdoor. There is a software which we use to turn a city into a learning environment. You can do it online. You can use it in virtual reality. But now we have started to collaborate with museums to to go to the museums and then have students model the different arts. And then we are developing a theory on how to connect culture, history, arts, geography into the mathematical modeling process. So we are using um, design-based research. So we are developing lots of examples in different countries. For example, in Egypt, Singapore, Indonesia, in Austria, in many different countries in South America, and then we are trying to see that how then this kind of modeling can be worked. And essentially, then this is extremely successful. Very young students who are working with technology and then get used to the games, and then they are kind of digital natives. They can do amazing modeling. So for example, this is done by fourth year students to model architecture either in their city or just choosing some architectures from what they found. So these are lots of different examples. For example, in Indonesia, in Egypt, and in a classroom and in the museum environment. So students are really proficient doing this. And the role of the teacher is to find out that how we can connect it with the subject, how we can connect it to mathematics, and then how we can use this kind of knowledge of students to use it in the environment. So then this is augmented reality. It's already available for everyone, but we can use it for 3D printing. So for example, then this is a GeoGebra AR, which we did a project in Indonesia to model this national monument or this mosque, which is very famous in Indonesia. The essentially very young students are modeling this kind of work, but also we can do it in modern architecture in lots of different places. So you can choose the different architectures wherever you are, even just simple houses, and then it will give lots of opportunities for modeling. But also, it's not possible all the time to travel to these places or find this kind of architecture. So we developed a virtual reality set to use in this kind of modeling for the architecture. And then also you can use it for 3D printing. So we have lots of printers, and then we are setting up labs in many schools and in teacher training institutes to be able to do this modeling not only in digital environment but also create physical resources. And it is possible that you are going from virtual reality to augmented reality to 3D printing, and then use this process for the learning environment. So this is the role of the teacher, that how to utilize this environment for the students. But I know that not all the time it's possible to have this visualization with technology. So you can use any kind of activities. So we are doing these projects not only with very sophisticated technology, but you can use blocks or any kind of wooden objects, or you can use origami, just simple papers to do this kind of modeling with architecture. But we can use it in any kind of arts or any activities as well. Probably many of the students have Legos. We can do this kind of modeling with Legos, and then it's also give lots of inspiration and opportunity. We are working with a Korean game which is called 4D frames, but you can just use some straws and glue to be able to do this kind of 3D modeling and then investigate this together with the students. And then also you can visualize data. So for example, we are collecting lots of data together with the students for sustainable development. And then you can use, for example, Lego or different kind of blocks to move statistics to the physical spaces and then show students that what is interesting. And then in GeoGebra, you can create entire cities just using the desktop tool. And then you can create videos to explore the different kind of architecture. And I know that many of your students are working, or it's Minecraft is very popular. So we have a big project on Minecraft where students design their own city and then explore the mathematics within Minecraft and then doing experiments in their own cities within this project. So it's very, very interesting to see. But you can use any kind of architecture, any kind of game. So we can just look at the famous architecture around you or using this. And then how do we connect it with games? So for example, this is um, with Polyuniverse, but also you can have this kind of art modeling with GeoGebra, and then also in GeoGebra you can move from 3D to 2D, and then use the opportunities to have this kind of work with the students. But probably some of you already know that 3D scanning is also becoming available, and then it's used in many work. So I have one kind colleague who is scanning art objects, and then we can use this kind of scanning. There are some scanning software on the phone as well, but now we are experimenting with scanning. And then also we started to collaborate with robotics groups where we can print essentially furniture or any kind of objects which we are scanning. Even we can scan a student and then we can print the replica of the students. But we need to look at that how to investigate the science and the mathematics behind these kind of activities as well. And then in the museum environment, we are collaborating with the National Museum of Egypt and the Ars Electronica Center. You can just take the students with their phones, and then they can do the modeling in the museums. And then when you return, then you can print it, you can integrate into virtual reality environment. And then also, as I mentioned, we are trying to connect not only physical objects but movements of the body, which is also a 3D modeling. So we are experimenting with mathematics and dancing. And as I mentioned to you, next year we are releasing a new app where you can have the students dance and then use mathematics. So and then that is a whole different topic. But we want to integrate all different kind of arts into our work. And then what is interesting that you can use this kind of technology in the classroom, but when the students are going home, you can turn a city into a learning environment. So we are developing and collaborating with a project called MedCity Map. So you can turn your city into a learning environment. So students are walking home and then they are solving mathematics puzzles on the way. But we are doing it to have students. So for example, during COVID, students had to work outside and then they had to model some architecture around them, and then we printed and then we used it for mathematical investigations. But what is interesting that my colleague Adi is in Indonesia, and then this kind of mobile learning environment is becoming part of the Indonesian curriculum. And then we are creating thousands of mathematical trails in Indonesia and in other countries too, to do this kind of investigation. So, for example, you can use augmented reality, but you can use the different tools to do this investigation as well. So you can turn your city into a learning environment. And then also we are doing it in many different places in Latin America. We have a huge group working in Argentina, Uruguay, Chile, Brazil to do this kind of modeling, and then we are running some summer schools there. So as I mentioned to you, that all of the things that I showed to you, we have lots of research. So I have about 40 PhD students working on these topics. So if you are interested, I will send you the list of the publications around all of these topics, and then you can use this. And then what is important that if you are a teacher, I can send you links, and then you can try this in your classroom already. So with GeoGebra, we are open source, so all of the materials or all of the things that I showed to you is available for your investigation. So what we are trying to do, that how we can use in this kind of investigation in the classroom. So we do lots of research, and then what we try to do is that how we can create teacher training to have this kind of environment, and then try to see that what kind of tools we need to provide the teachers, how to prepare the pedagogy, but also how we can what are the problems which is hindering this kind of process. Of course, many times it's the curriculum, because it needs lots of time for investigation, but students really appreciate and then they learn a lot in this kind of environment. But it's very important for us to have this kind of transdisciplinary learning. Of course, mathematics is fundamental for this kind of transdisciplinary learning, but we can make the environment interesting. So what we try to do is that trying to have this concept of connecting this kind of environment, but develop the idea of STEAM plus X, where we can connect culture, diversity, and different science. And then we are using it now for architecture, but we can use it for history, we can use it for geography, we can use it for literature, for dancing, and then in different kind of places. So we need to be creative and we need to be innovative in the classroom to be able to inspire students. So we are developing this concept of STEAM plus X, and we want to develop a theory that how we can bring it into the classroom. But another thing which is very important is inclusion. So most of our project is visual, but we need to be aware that there are students with different kind of learning disabilities, or visual impaired students, or hearing impaired students. So we are developing all of these projects in mind to be inclusive. And then, for example, we use 3D printing for students with visual impairment, and then we use it in mathematics and in biology, and then used in this kind of inclusive education as well. So what we want to do is that include all of the students, and then doing this kind of modeling for, or these kind of activities for all the different purposes. So what I showed it to you now is that we are developing this innovation in 3D modeling, but we have lots of projects with arts, with visual arts, and for example, my student from Indonesia is working on digital comics. We are also experimenting YouTubing. We look at social media as the environment. We are working on memes. So we want to integrate all of the culture then that is a possibility for students. But it's very important to do research. So we are developing a phenomenological study that how we can integrate all of these activities in the classroom. And then we are categorizing the activities, categorizing the way that where do we start? We start with simple examples, and then we are moving to very sophisticated modeling that you have seen here. And it's very important for us to make sure that what we are doing is not only just cool work, but also it contributes to the development of the teachers, and then contributes to the learning of the students. Do I still have time? Because maybe you need some time for questions. I can talk a little bit more about the theoretical aspects and then also the methodological aspect. But if you think so on, then the next topic would be theories, which might be interesting. So should I talk about it, or
Um,
we need time for discussion?
you may continue, Prof.
Okay.
Continue.
So what I wanted to show here is that we are not only developing innovation in the classroom, but we are developing innovation in theories. So maybe I just show you some work that we need to capture in this kind of theories. So what we try to do is that try to connect the different research fields with different theories, and then we have an experiment with my colleague in Qatar and Lebanon to connect the students, the teacher, and the content, and then also how we can use the innovation, and then how we can use the different kind of innovation theories into 3D modeling. But what is very important that we need to create not only an environment where this kind of learning can take place, but also an ecosystem which includes all of the people in this ecosystem. So we want to integrate the students, the teachers, the teacher educators, parents, the policymakers, administrators, curriculum developers, because this innovation wouldn't be possible without the people who are involved in the education process. But also we need to create books, technology, hardware, software, and all of the resources to make it possible. And then also to be able to do it in this kind of innovative teaching, we need to prepare the teachers very well. And then we need these theories that what is the possibility to integrate this kind of theories. So maybe I just skip some of this kind of theoretical part, but focus more on the methodological innovations. So we are using a lot of in our work is design-based research. And design-based research is that we are developing an idea, and then we develop the ideas together with teachers. So for example, for augmented reality, we develop some ideas with the teachers. We are collecting lots of data. We observe the classroom, we interview the teacher, we have lots of feedback. Sometimes we do questionnaires, and then use this data to analyze, and then to be able to develop the next cycle better. But what we found within this kind of design-based research, that many times we need to develop new innovation, and then also the technology is changing so fast that by the time we are finishing a cycle, there is a new kind of environment emerging. So we need to have a more fast-paced work for our research. So what we are trying to do now is that trying to do this research combined with user experience research. So user experience research is mostly used in technology or in marketing. So in that case, we are trying to combine the traditional techniques of design-based research with user experience research. So we are investigating for example, personas. And we have lots of work, A/B testing, and now we started to do eye tracking. That how we can make these environments into much more feasible and then much more fast-paced. So, for example, we have lots of studies on personas, and I don't know if you know about personas. Then this is a technique is used by technology educators, and then, but for example, like Facebook and Google create personas to target the audience. So essentially, you are in a target group, which is so the personas are just virtual people, but these virtual people are representing part of the population. So essentially, when we are talking about students and teachers, then we are saying that all students and all teachers are the same. But we know that all students, and then there are different kind of students and different kind of teachers. But with the use of personas, then we will be able to develop virtual representations of different groups. And then when we are designing workshops for teachers, then we will, or for students, then we will be able to identify the personas of the students, and then we can target them much better than it's a general teachers. So we are trying to we are trying to develop these personas for students. So we did a study on developing personas for students, and now we are developing personas for teachers to be able to do our research much more focused for the target group. So, for example, teachers on the countryside in big cities are different. Maybe there are schools where there are lots of technological resources. There are schools which are less resources. So, in that case, whenever we are finding out that what is the needs and the requirements of the teachers, then we can create these personas, and then based on the personas we can design our teacher training, which is much more efficient than just saying that all the teacher training needs to be the same. But what we do through the UX research and the personas is that we can much more target the group. And then, of course, we are doing usability research with eye tracking for GeoGebra for the interface, but we are trying to do this for the augmented reality, the VR, and the 3D printing work as well. So this is our research methods. And then, as I mentioned to you, I will show lots of uh, experiments. And um, we are running research schools to train teachers and then train researchers, but we are working on many different aspects. And thank you for your attention. I'm sure you have some questions, and I will share all of the resources that I showed to you. But what I want to say that this is only a fraction of our work. We are doing so much more projects. So if you are interested, then we are working on any kind of innovation which needs to be integrated into schools. So thank you very much.
Question.
After conclusion. Yes, thank you very much, Prof.
Thank
Yeah,
you.
dear ladies and gentlemen, we hope aligned to our country's vision and mission towards IR, IR 6.0. Okay, we are emphasizing on STEM, STEAM, and now towards to STREAM. Okay, this STEM is science, technology, engineering, arts, and mathematics. But this A we can also refer to architecture, right? Architecture is the only art that you can't help but can feel. You can avoid paintings, you can avoid music, and you can even avoid history. But good luck getting away from architecture. This is not from me, this is from Philips de Vario. Right. Today, we have heard from our profs sharing about background and context of STEAM, GeoGebra, about the usage of 10 million users of GeoGebra users in this world in mathematics. So how beautifully he described the GeoGebra usage in modeling, 3D modeling. So research on technologies that is refers to 3D modeling in teaching, innovations in ecosystem research, augmented reality, what we are saying all the time, AR, VR, okay, augmented reality and virtual reality, and also inclusion. Just now our prof already covered all this with us today, and he leads that to innovation theories and the need for the future methodologies and directions towards creativity about interdisciplinary education and research. Right, with that, let's open question and answer session now, ladies and gentlemen. Over to our moderators here. Thank you.
Okay, throughout the sharing session, Prof sharing session just now, we have a lot of comments, especially the emojis, the positive emojis, the positive whites throughout our comment section in our YouTube. All right, Dr. Lawa, I believe that you have one question that you want to read out.
Yeah, Dr. Nora and Dr. Kalai. Thank you. Thank you, Prof. The application of mathematics in different area, arts and mathematics, music and mathematics, history and mathematics, geography and mathematics are explained very well, and they are all awesome. Extremely great. We were like, wow. Prof, now with your explanation just now, I have, I think we also get the same questions from some of our audience. What are the barriers or constraints you face when dealing with this thing? A delay in the real world.
So I think one of the main barrier is the curriculum many times, because one what is being done is that we have a curriculum where we want students to take a test, and then taking a test, it's not necessary that they understand mathematics, but they are very good in taking tests. And then most of in this kind of tests, the students demonstrate that what is the content knowledge in the subject is. But with our projects, it takes it takes time, and then also a lot of freedom for the students, which they really like. But at the same time, they are developing their skills of collaboration, modeling, and so on. And as a side effect, they are also learning the topic. So most of the time, they will be able to do the test as well. But if you see that whole education is developing, that we need much more focus on skills, and then we are developing the skills and the creativity for the students and the content as well. So we can pick the content. But many times the curriculum is just very rigid, that we want to examine only the content, and then also the skills are much more difficult to measure. So then that's why the curriculum and then also the policies have these kind of things. But we have to do this because we need to think of the future. And the other barrier are the teachers. Because the teacher think that it's too complicated and it's very difficult to do this kind of work. But we can prepare the teachers, and then essentially most of the time our task with the teacher is to make the teachers believe that it's possible in the classroom, and then also accept that the students are much better using the technology than the teachers. And the role of the teachers will change because the students are very good. And then the teachers start to learn from the students how to do this kind of work. So the teachers don't have to know all of this kind of 3D modeling. They have to have an idea, but we cannot compete with the students because they are living in this kind of 3D modeling world, so they can do it. But the role of the teachers should be to make sure that the students also learn the mathematics and then they learn the skills through this kind of exercises. So we need to change teacher education in a way to make the teachers confident that they don't have to know everything, but they have to be like mentors and then leaders of the students with this kind of environment. So I think these are two barriers.
Yes, thank you, Prof.
Yeah, Prof. Your explanation was very well. As we understand, teachers play a good role, especially being a facilitator.
Yes.
Thank you, Prof.
All right, Prof. There are many things, many points that make me enlightened to know more, especially on the personas that you are talking at the end of your sharing session just now. Okay, you are taking it as the teacher training. For the personas, you use it as the teacher training. How far that you believe that personas can be used for the teacher selection process?
And it's a good question. So, but what we did then that we did a huge survey in Austria to develop personas for teachers and then also develop personas for students, and then we can target our teacher education courses for them. But for admission of teachers, I think we need to develop different personas than the personas which is for the in-service and pre-service teachers, and then we can use this. But many times we have this possibility. So, for example, in Austria, there is a huge teacher shortage. So then there are lots of students are studying something else, but they don't want to be teachers. So it's very difficult to have all the teachers. Of course, we need to select them. I don't know exactly how it is done. But for example, I work a lot in Finland and in Estonia, where the teacher is a very prestigious job, and they have a very thorough interview process. And then through this kind of interview process to become a teacher, I think personas could have a very valid way to select teachers, because what we want to do is to identify the teachers who can be like innovative, who can be ready to change their perspectives and then become more like a guide in the classroom rather than just transmitting the information. But then that is a very difficult task. So I think it's a very good question, and then I will think about it. But it depends on different countries where there is a teacher shortage. I think schools want to have lots of things, but what we want to do is that really finding teachers who are flexible and then who can be good guides and then inspiring in the classroom.
Comment section. Sekolah Jenis Kebangsaan Tamil Bandar Spring Hill.
Again, you repeat again.
Okay, Prof. When we are looking at the comment section, There one comment from Sekolah Jenis Kebangsaan Tamil Bandar Spring Hill mentioning that good teacher can inspire students' performance. And I believe in
Exactly.
your sharing. Sorry, Prof.
Exactly. I agree. So I think now we don't have to teach because we have all the possibilities and the technology, and the students find all the information. What we need to do is that inspire the students. We need to give good questions. And then if we give good questions for the students, they do it by themselves. And then also what we need to do is guide them that not to go too far away from the question. So essentially, this is what I'm doing in my doctoral school to have. So I don't teach. I ask
Yeah,
questions and then
we may
I
only
inspire
facilitate.
students. Yes,
Yeah.
I'm sure you are doing it too. But
Yes.
many
Yes.
times, many times it's very difficult to explain to people that we don't have to teach as teachers, but we need to be like inspirers to the teachers and to the students.
Correct.
Yes, Prof. So, Prof, I'm interested in just now a word that dancing with mathematics from Indonesia. So, can you explain a little bit about that? I'm interested to know what is dancing with mathematics.
Oh, okay. We just published a paper and then we are developing an app. I don't know if my colleague shared his. I can share it with you, and it's. Let me check if we have the slides. Not yet. So what we are doing. So I can share. We just published the paper with my colleague in Cambridge and Indonesia that we are developing a software or an app when we can use mathematical movements. So every movement, like what we did with cities, that you can turn a city into a mathematical learning space. But we can use any kind of movements into mathematics. So probably this kind of representing the sine curve and the tangent and the line and so on. So we can do it in this kind of work. But what we are doing with this kind of software, that we can use the movements of the students, and then we can integrate it into GeoGebra, and then we can investigate functions, we can investigate um, shapes and angles and so on. So we can use any kind of movements. But at the
Oh,
same
very
time,
interesting.
what we can do is that, for example, for computational thinking, that we can use like coding to create dances. So either you can do some kind of coding and then we can connect it with some kind of small robots or something, and then we can make like a dancing robot by just mathematical connections with this kind of work. So
Uh-huh.
today we are designing so we are in the process of, we have a big project on mathematical dancing, and then also we also have big performances in theaters when you are dancing mathematical concepts, and we have and then also for traditional dancing in Indonesia. I can send you the paper. So we are translating the traditional dances into mathematical concepts. And one of my colleagues just published a paper about Argentine tango, that how the shapes of the movements can be used for teaching. And then, of course, we have lots of projects on mathematics and music, which is investigated for a long time. And I have two PhD students on looking at music and things. So music, dancing, and mathematics is very highly related. And then what we want to do, that we need to integrate all of the subjects, all of the movements. So we can have any movement of the hand, then that is also a mathematical investigation. which we can use
Yeah.
in the classroom. So then that's what we
Yeah,
want to
it's
do
interesting.
with our projects. That so mathematics is in everything, but we don't
Yes,
utilize it.
yes.
We are doing the many times the stupid examples that how many bananas you are buying, when you can just use your hands as a mathematical tool to investigate. So then that's our goal, to investigate any kind of crazy idea which could
Yeah.
lead into learning, and students really enjoy it.
Yeah, interesting. Well, yeah, we are really excited with the another M in STEAM refers to music,
Yes. So we
right?
have lots of projects on music, and then probably you know that in GeoGebra you can have music, or you can have sounds. So we can
Yeah,
turn functions into sounds, and then
yeah,
also one of my students is developing an app to translate geometry and functions into sound. So you can create different objects. I can show you some videos that how he's doing. So you can turn 3D objects into sounds, and then you can
so
choose change them to create your own music.
yeah. Thank you, Prof. Thank you very much. It is quite interesting. Yeah, over to you, Dr. Lava. You have anything?
All your sharing was interesting, Prof. We learn a lot. As
Yeah.
time is limited, we have to end our session here. Before we end, I would like to thank and congratulate our director, Dr. Azman, and Deputy Director, Dr. Azahar, for giving us the opportunity and support to conduct such a memorable session with Prof. Zsolt today. The organizing team from Mathematics Department, the technical team, Dr. Mat, Mr. Zabidi, Tuan Haji Ishak, Mr. Zaid, and Mr. Mahin for their high-tech support to make up this event. All the audience for your kind attention and participation, of course, your comments and sharing and likes. And never forgetting our Professor Zsolt for your scholar knowledge about STEM in mathematics education. We really appreciate as you are with your busy schedule and willing, though you are not here, but virtually you present here,
Yeah.
Prof. Hope to see you again with more
Yes.
sharing in the future. Really
Thank you
appreciate
very
your
much.
sharing, Prof.
Thank you, Prof.
We are really happy to have you here today.
Mhm. Yes. So it's really great to be here, and then I have lots of students from Indonesia and from Asia, and then next year I will be spending some time in Indonesia and in Thailand. So maybe we can organize some
Yeah.
things. So it's very exciting that how you are developing mathematics and STEAM education in Southeast Asia. So I've been there at least 15 times, so I have lots of experience. Okay.
We really welcome
And then
you, Prof.
Malaysia.
if you plan to collaborate, we are always happy to host and then do some joint projects. And I have lots of probably 10 PhD students from Indonesia. So if anyone would like to do a PhD from Malaysia in our center, then I would be happy to host students from there. And of course,
Definitely,
colleagues
Prof.
as well.
Sure, Prof.
Okay. Thank you very much. And then
Thank you.
have a
Thank you
nice
for
day
your
for
time.
everyone. Thank you.
Yeah.
And all your
Bye-bye.
sharing.
Yeah.
Thank you, Prof.
All right.
Yeah. Thank you, Prof. Thank you.